Okay guys, welcome to this section of the course where we're going to learn all about the parts that we will be using throughout the course. In this lesson, we're going to be looking at the three-phase motor. Three-phase motors are the backbone of industry, and we use them for many different things like fans, conveyor belts, crushers, stirrers, mixers, and all sorts of equipment that you would find in commercial, industrial, and agricultural places. Why the three-phase motor instead of the single-phase motor? Well, three-phase motors are more powerful and more efficient than single-phase motors. This is a squirrel cage asynchronous induction motor. It's quite a small one, as you can see in relation to my hand. And here we have our rear cover that covers the cooling fan at the back. We have our shaft sticking out the front here. Here we have the feet of the motor on the underside. Some don't have feet, some have a flange at the front for mounting to things like water pumps and stuff like that. This one has feet though. On the side here we have our motor nameplate. We're going to take a closer look in a second. And at the top here we have our terminal block. Now, let's have a look at our nameplate. This is where we can see what the ratings and capabilities of the motor are. We can see that this is a 50 Hz motor to be used with a 50 Hz voltage supply. And we can see that this number represents revolutions per minute. This means that the shaft will turn 1,340 times per minute. Now, it's a very small motor. You can see its power output is 0.18 kilowatts, or if you're a horsepower person, 0.25 horsepower. Now these three ratings are all related. These two voltage ratings here show us that the motor can be connected to either 240 volts or 415 volts. But don't be fooled. 240 volts does not mean single phase. Okay guys? It means that we can connect the motor to 240 volts three phase or 415 volts three phase. Now, if we were to connect the motor to 240 volts three phase, we would need to connect the motor in delta formation. That symbol there stands for delta. And if we were to connect the motor to 415 volts three phase, we would need to connect the motor in star formation. That symbol on that side stands for star, that little Y there. Now, if we were to connect the motor to 240 volts three phase in delta formation, the motor would draw up to 1.15 amps per phase, depending on the load. And if we were to connect the motor to 415 volts three phase in star formation, the motor would draw up to 0.67 amps per phase, also depending on the load. Any more than this and we know that the motor has become overloaded. Already, without going into the full-blown maths of the motor, we can see that when we give the motor less voltage, it draws more current if connected in delta to give the same power output as more voltage with less current when connected in star. And don't worry, we'll look at how to connect the motor in star and delta next. Now these numbers here, here, and here have to do with the type of build of the motor, its insulation class, and its ingress protection. These all basically tell us some more physical and electrical characteristics of the motor. Some motors come with more detail, some come with less. But we're only really interested in the practical operation and control of the motor, so we don't really need to know too much more at this stage. Okay guys, let's wrap up this lesson here, and when we come back, we'll take a look inside the terminal block and check out how to wire up the motor. Cheers!